So now, if when n goes to infinity, sorry, big N, I should say, when big N goes to infinity, as you know, now if, let me, as big N goes to infinity, E of n goes to 0, then we say that the approximation in the mean converges. Converges to the function. Okay. And as a result, we have okay. So this happens only when this happens. The Bessel identity is valid whether or not this happens. Okay. But if this does happen, then we get a limiting form of Bessel's identity. Essentially, the Bessel identity is saturated, right? And this is called Parseval's identity. All these famous 19th and 18th century mathematicians. Okay, so this is the mathematics part. And I want to close this by giving an interpretation of Parseval's identity, which I think is very important. Okay. So interpretation of Parseval's identity. So the conceptual interpretation, in the next class, I will give you more of a quantitative interpretation. So what is interpretation? That suppose we have a class of function. We have a class of functions, each of which, like each member, I mean, of which each member, I should say, class of functions of which each member satisfy Parseval identity. Okay, so each member satisfies this thing. Okay. So in that case, every member of that class must be expressible as a linear sum of e to the power 2 pi I n x over L. Because otherwise, because if there exists a function which does not, because let me rephrase this. if there exists a non-zero function, satisfying the Dirichlet conditions, in that class, that doesn't, that is orthogonal to e to the power 2 pi I n x over L, meaning that you cannot express it in terms of this, guys, then, for that function, the CNs are all 0 for all n. But we know that since it's a non-trivial function, it's a non-zero function, this thing must be non-zero. And so, according to Parseval's identity, we have a contradiction. Because all the C's are 0. If all the C's are 0, then the right-hand side of Parseval's identity would be 0 for that function, but we see that the function is not 0, the left-hand side. So we conclude that every function in such a class must be expressible as a Fourier series. Okay. So this is a bit of mathematical sort of meandering that I usually don't go into, but I thought it's a good idea to at least touch upon this. Hopefully when you take real analysis or some other course, you will be in a position to ask your instructor more about why, about these ideas, okay? But any questions so far?